So, welcome back to our lecture, and today what we are going to do, we are going to see how we can add numbers in octal, binary, hexadecimal. So, in order to do so, what we will first understand is the addition operation that we normally is very familiar in doing in the decimal number system. So when we add two numbers, suppose we take any two numbers, maybe 2, 4, 7, and suppose I take 5, 3, 4. So we want to add these two numbers. So what we do here? So you know that we do it like this. So 4 plus 7 is 11. So we have 1 here, and we have a 1 as a carry, and then 1 plus 4, 5 plus 3, 8, and so 8 there is no carry, and 2 plus 5 is 7. So 781 or 781 is the answer. So this is true in case of decimal number systems, and this is the way we go ahead in all other number systems. However, there is something different in the other number systems. Because there is what is the difference? The difference is that the radix or the base is different. So we need to understand the addition operation in the decimal number system a bit more deeply in order to generalize this algorithm of what we are actually doing, why this borrow is why this carry is coming. Okay. So this is what we need to understand from the perspective of the decimal number system, and when we understand that, we will be very easily be able to do that same thing in octal number system. So, however, suppose we want to do the octal addition just how we did it here. Suppose these two numbers are in octal, then suppose these two numbers are in octal, then what do we have to see? We have to always do this conversion, like 7 plus 4 is 11, we know, but 11 in octal is basically 1 3 1 3. Just calculate it in your head, it is 1 3. So 3 is here, and 1 is going to the carry. So 1 plus 5 is 1 plus 4 is 5, and plus 3 is 8, but 8 in octal is 1 0. So we are putting a 0 here and 1 here, and then 1 plus 2 is 3, and plus 5 is 8 again. So 0 and 1 here. So this is the octal addition. You can verify by converting this to the decimal numbers and see that this the decimal equivalent of 247, the decimal equivalent of 534, and the is adds up to give the decimal equivalent of 1003. You can do the conversion to decimal and verify that this operation holds true. What we needed to do, we needed to always keep a track of what is the addition, and whatever value we are getting, we have to convert it in octal. We have to represent that in octal. So this we have to always keep in mind. So what becomes a problem is when we will have numbers more than 2. Suppose we will have another number here. Okay, 165, maybe some few more, 412, and then I say that all these are in octal. Now you add them up. Okay, so of course you can add two together and then add the third to the result, then add the fourth to the result, but that will take a longer time, and addition can be done in a quicker manner. Because when we do the addition, this sort of addition, supposing these are decimal numbers, so suppose these are decimal numbers, we don't do addition like we add 2 and then we add the third and then we add the fourth. We don't do it like that. We add all these 4 together in decimal, right? So when we add this 4 together in decimal, then how do we do it? Again, we go by the same process and we see what is the total, and there would be a carry. So there will be some number put here, and there will be a carry that will be taken next at the next position. So let us quickly do this for the decimal number system, not for the octal right away. So we are trying to understand the process actually, what is happening. So 2 plus 5 is 7, plus 4 is 11, and 7 is 18. So 1, and then 1 plus 4 is 5, 8, 14. Let us take this as 5. So we get 21, I think. 5 plus the 8, 14, 20, 14, no, sorry, 14 and 7. Let us take 7 here. So we get 21. So we had 2 here. Then 2 to 4, 9, 10, 14. 1, 4. You see here, previously we were getting a carry of 1, but we can also get a carry more than 1. Right? So what is happening here? When we are getting the carry as 2, what has actually happened? So for that, let us look at something. So this is like a clock that I am drawing, and this is having numbers. So 1, 2, 5, 6, 9. It's 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we come back to 9, then we again go to 0. Right? So suppose we want to add this 7 and 4 and 5 and 2 together. Then we note what is the first number, 7. So we start our counting from 7. We have to add 4. So we go like 1, 2, 3, 4, we reach here. 7 plus 4 is 11, right? You see, when we go from 7 and go 4 units like this, then we reach this 1, and we have crossed this 0 once. So we have crossed once. So this 1 is basically going as the carry, because we have crossed the units place basically once. Okay, so the number would be 1, 1, right? 7 plus 4 is 1, 1. However, we have other numbers to add also with it. So after reaching here, we have to further add 5 units ahead. 1, 2, 3, 4, 5, we reach here. Then 2, 1, 2, we reach here. 8. You see the 8 is coming here. How many times we have crossed this clock, the 0 position, the starting position? Only once we have crossed during this entire process. So this 1 comes here. Now you see, when we are adding these numbers, so we start from 1. So our starting position is here. Then we have to add 4. 1, 2, 3, 4. Then add 3. 1, 2, 3. Then add 6. 1, 2, 3, 4, 5, 6. We have crossed the clock once, right? We have crossed the clock once. So after adding 6, we have to further add 7. 1, 2, 3, 4, 5, 6, 7. So we reach here, but we have crossed the clock twice. So it becomes 2. So we have to keep a track of what? Only how many times we are crossing the clock, crossing the 0 position. That's what we need to keep the count. And where we reach is exactly what we write down here. So this is like a diagrammatic representation of the algorithm that we follow, and this diagrammatic representation will help you to do the addition operation in all the different number system, any number system of any base that you can think of, that you can challenge yourself with. You will be able to do the addition if you follow this algorithm of the clock. Okay, this this 2 comes here now because we have crossed this clock twice. Now you add these numbers 2 to 4. So you start from 2, right? You start from 2 here, add 2, 1, 2. So you are simply moving your clock hand, like as if you are moving your clock hand, or as if you are going through this clock positions by as many numbers as indicated, as many units as indicated here to add. So you simply walk 2 units, reach here, then 5, 1, 2, 3, 4, 5, reach here, 1, you reach here, and 4, 1, 2, 3, 4, you reach here. You have crossed the 0 mark once only now. Once only you have crossed. So 1 and 4. 4 because you reached ultimately at 4. So 4 and then 1. So this is how it happens. So if I now say that this is the addition operation in decimal, I highlighted, but suppose the addition is in octal, then what would happen? Then this clock will change basically. This clock will change. How it will change? It will contain only values, only numbers from 0 to 7. The starting is same as 0, 1, 2, 3, 4, 5, 6, 7. Because we don't have any other digit other than these 8 digits, 0 to 7. So after 7 we have to come back to 0, right? So now if you look here, suppose we have a number 245. So now these numbers are in octal. Okay, so even if I don't write the suffix, you must assume that we are working in octal. Suppose these are the two numbers 245 and 716. Okay, and we need to add this. So let us just do the decimal equivalent, write the decimal equivalent. So if you find out the decimal equivalent by doing the summation method here, 2 into 8 square plus 4 into 8 plus 5, then what you will get is 165. If you add up 716 like that, you will get 462. So you should check this because I am copying this from my handwritten note, so there might be some mistake. There is no mistake actually because this adds up, so this should be like this. Okay, so now you find out what is the addition of these two numbers. How you are going to do it? Same way as we did in the clock for the decimal number system. So you start with from 5, because we are starting with 5. You start from 5. How many units do you need to add? You need to add 6 units. 1, 2, 3, 4, 5, 6. You reach here at 3. How many times you have crossed the clock? You have crossed the clock once. So you have to only keep a track of how many times you have crossed 0. Okay, so when you reach 0, immediately a flag is raised. So how many flags are raised? That is what is giving you this carry actually. And where you reach is giving you this number, what you write down here. So now the carry is only 1. So now you start from 1 in the next position to add. You start with 1. You go 4 units, 1, 2, 3, 4, and then again 1. So you reach 6, and there is no carry. because we have not crossed this 0 mark. Next, 2 plus 7. So you start from here. 2, 1, 2, 3, 4, 5, 6, 7. You reach here, you have crossed the 0 once. So 1163. So you can try to do what is the decimal equivalent here. So this, because this is 8 cube, so you try to do it here, and this should purely match. So I have not done this actually, and I am not doing it right now. So I will show you another problem. Now if we need to add more than two numbers, so if we had only two numbers, then maybe we could have done it just mentally without even referring to this clock. But if we have more than two numbers, then the clock comes to use in a bigger way. So suppose we have this number added to it, 127. Okay, 127 is basically 87 in decimal. So what would be the result? The result would be 7 plus 9, 7 plus 2, 9, plus 5, 14, 9, 21, 6, 7, 714 in decimal. So this should be equivalent to that. So let us see how it comes as. So we can start with 5. We can also start from the bottom top. So any or top down or bottom top, but we need to only take care that all the numbers are covered. That's all. So let us start with 7 just to give a different flavor. So we are starting with 7 and we have to go 6 steps. 1 already crossed once. 1, 2, 3, 4, 5, 6. Then 5. 1, 2, 3, 4, 5. We are reaching here. We have crossed twice. So we are reaching 2. We have crossed twice. So 2 here, 2 here. 2 starting from here. 1, 2, 3, 4. Then 1. Then 1, 2. We are reaching here. We have crossed only once. And we are reaching 1. 1 plus 2. So 1, 1, 2. 1, 2, 3, 4, 5, 6, 7, 1. Reaching here, we have crossed only once. So 1, 3, 1, 2. And if you convert this, you will get 714. How you can verify? You can also verify by doing the division algorithm on 714. Because sometimes conversion of these 8 cube you have to do. So you might not have the calculator with you. So you simply do the division here. So when you do the division, you will see that this is 8 and then 9, and you have 2 as remainder, then 8, 1, 1, you have 1 as remainder, 8, 3, 1 and 3 as remainder, and 8 getting 0 and 1 as remainder. So the number is 1312, 1312. Same. So in this way, you should always double check your results, at least in the beginning, whether you are doing it correctly. So this is about octal addition. So if you are given addition in hexadecimal or binary, you can follow the same way. So I hope you will be able to do the addition for any other numbers. I have shown you the general algorithm. And suppose you are having a binary number, then in binary what is happening? We are having only 0 and 1. Okay. So as drawing a clock, you can draw or you may not draw. It's up to you. Only two numbers are there. So suppose we are trying to add now these two numbers which are in binary, and 0, 1, 0, 1. I put the 0 here. We may not have put it, but just to maintain the length of the word, we are putting the 0 here. We need to do the addition. So 1 plus 1. What is 1 plus 1? We know that 1 plus 1 is 2, and in binary 2 is basically 1, 0. So we have to write a 0 here and take a 1 here. However, going by this same clock logic, you start from 1, you go one step, so you reach 0, but since you have reached 0, you have to add a carry here. Okay, so that is why this 0 is coming here and the 1 goes as the carry. Now you have to add this 1 with this 1, so you are getting 1 plus 1, which is, again you start from here 1, you reach this 0, again you are getting that. Again there is 1 and 1, again you will get the same, again you will get the same result. So in this way you can do the binary addition also. So we should next try the addition with more than more than two numbers. So let us add some number here. Suppose add 0, 0, 1, 1. Suppose I work with three numbers right now. So we have to start, so we have to add three ones. So this is 3, 1 plus 1 plus 1 basically is 3 in value, but that value represented in binary is 1, 1. So a 1 would come here and a 1 would go to the carry, right? But from here we have to see, if you see the diagram, so from 1 we are adding 1, we are going to 0, so a flag is raised once we have crossed, then again coming to 1, so we are keeping it here 1 and then adding a 1 here. So again we are doing the same thing, so there are 3 ones, the same thing will happen, 1, 1. So for this one only only 1 is added, once it is added, so from 1 we are going to 0, so 0 and 1, 0 and 1. So this is how the addition goes, and you can check the decimal equivalent, you can check. So this is what, this is basically 9 plus 2 is 11 in, this is not 1 1 in binary, 11. What is this? This is 5, this is 3. So by the addition you should have gotten 19. Let us see what we have got here. This is 16, this is 2, this is 1, so you have got 19. So you should always verify your results when you are beginning with this sort of things. So we have verified the result and we have seen that the algorithm works. So we may not always go back to this clock algorithm when we are working with decimal, or even binary is very easy. As you can understand, binary is also easy. But when we are doing with octal or hexadecimal, this clock is very useful. And for any number system, general number system, this clock becomes very useful. So this is what we showed is the binary and the octal. Before we show an example in hexadecimal, let us try to see one more example in binary, where actually you will cross this 0 twice or maybe more than 2, and when that happens you have to write 2 or 3. Suppose twice you have crossed, you have to write 2 here, and this 2 will come as a carry, right, that time. But since 2 is not a digit in your binary system, so you have to change this 2 to 1 0. So as the 2 is getting represented in binary, and use this 1 0 as the carry. So how this is put in the carry position, so that is what we are going to see in this example. So let us add one more number here. Suppose we are adding another number 1001. So now you see that this first position itself, so 1001 is 9. So you should get 28 as the result, and you can convert 28 and find out what 28 looks in binary. However, what we are trying to do here, we want to try to add these numbers. 1111 is 4, and 4 is basically 100 in binary. And similar thing you see we are obtaining by this particular algorithm. We are going from one, so we start with 1, go once, twice, thrice, 1 1 1. So we come to 0 twice and we end up at 0, right? So we end up at 0, come to 0 twice, so we have to write 2 here, but 2 is not a number in binary, so 2 is converted to 10. So what is happening here, we write the 0 here. Instead of writing 2 here, we have to write 10 by taking up another position to the left. So now this becomes a carry. 0 is the carry to this particular position, 1 is the carry of this particular position. And both carries are getting generated from this particular position. So it is not always that the carry is only for the immediately next position. The carry may overflow. The carry may overflow to the next higher position also. And if it is more, next higher position also, it can so happen. Okay. So in this case, we see the carry has overflowed to the next higher position. And the immediate carry here is 0. Okay. So now you add, you will see that this is again, when you add this position now, this will be 0 and another carry is getting added here. Now when you are adding on this position, you have to take care of both these carries. So both these carries you add, and another one is also here. We have already seen this would result in 1, and a 1 would get as carry, and again a 1. And now just sanity check, you see this is 16, this is 8, this is 4, and all these add up to 28. So whatever I have told you is works. So this is the way it goes actually. This is the algorithm. So you put it in your head, and if you are given long numbers, don't worry about that. You simply, whatever carry is coming, some value would come as the carry. If that value cannot be represented by a digit in the number system, you have to represent it as a number in the number system, given number system. So like here it is 2, you represented it as 10. Suppose we are getting 3. Let us do an example where the carry would be 3. So the carry would be 3, right? So we have to add another number, 1001. This is okay, 9. And let us add another number, 1101. What is 1101? 1101 is 8 plus 4, 12, 13. Sorry, something I'm doing. 8, no, it's okay, 13. What would be the result? Just let us do the decimal first. 13 plus 9 is 22, 25, 30, 41. You should get 41. Now, in our addition, what is happening? Let us see. We start from 1. So, once we go here, one more, so 1 is here. 3 we have covered, the 4th again cover here, one more, and we have covered till here, and then the last one. you are again reaching. So we are 5 basically. So one more we needed actually. One more number we needed. So this will not do. Let us take one more number. Then we'll get 6. Then we'll get 3 here. Let us take simply. Let's take simply 0, 0, 1, 1. What is 0, 0, 1, 1? It is previously we had got 41, so this should be 40. Now you see that this is 3 plus 3, 6. Okay, and 6 is basically 110, right? So this 0 should come here, and 1 and 1 would come as carry here. Same thing you can observe from this. So you start at 1. How many times you have to go? 5 times. 1, 2, 3, 4, 5. 3 times you have crossed 0. So 3 times you have reached 0. So, and finally you are staying at 0. So you are putting 0 here, and 3 is as the carry. So this is 1, 1, 1. This is actually, I put some marks. So this should be 3 basically. And 3, since it is not a digit in binary, we have to convert it, and we get 1. That 1, 1 again comes here. And then you do the addition again. So here with the 1, 1 plus 1, 2, 3, 4. So we know what is 4 going to have like this. So 1 can coming here. So now again you do the addition, 1 and another 1 is coming here. 5 is. Now you can check whether this is 44 or not. So this is basically 32, this is 8, and this is 4. 32 plus 8 is 40, and 44. So you see how the algorithm always gives you correct result. So you put this algorithm in your mind properly, and you can work with it all the time, and it will always give you correct result. So let us see once the hexadecimal, or maybe we can see one octal addition, where we will get in octal, by getting a carry which is more than 7 is a bit difficult. So there will be a lot of numbers to add. So let us not do that. We simply, so I was trying to show you something like that, but it will be a bit too much, too many numbers to add. So let us simply go and look at the hexadecimal. So 0 to 15. So we have 7 on this side, 4, 5. A, this becomes a bit tight here. 9, A, B. So now you suppose you have this number again, COD, and another number EED, suppose. These two you need to add. Then you start from D, and you have to go, for, you have to go 15 positions, because you have to go 14 positions to the right, because E is 14. You start from here and then count 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. you reach at B. This is where you reach. And how many times you have crossed 0? Once. So you now add from C you start. Suppose from C, D is what? D is 13. D is 13. So you have to add 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Each. Okay, so again you have to add 1. So this 1 we forgot. So you are reaching basically A. And you have crossed 0 once, so 1. So with B you have to add only 1 to C. And you have not crossed 0, so there is no carry, or you can write 0 here. You may not write 0, no problem. So from A you have to go 12 units since C is 12. From A we are starting counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We are reaching here. So this is 6 and we have crossed it once, crossed 0 once. So 16CAB. 16CAB. So I urge you to do the decimal equivalent and verify whether this algorithm has given the correct answer. So I'm sure that it will give the correct answer. But if you are not finding or something is wrong here, you should again check back whether we have done this correctly or not, because I'm not doing it from my notes. I have just done it from my head. Might be some issue had been. Let us again double check once, just to be certain that we have not done any mistake. This eraser is quite broad eraser, so it erases all the things. 6, 7, 9, D, D. From D, E, C is 12. So you can also write this here, maybe 10, 11, 12, 13, 14, 15, just to, if you need, writing it here, because we know this with what values these alphabets tell us. So we don't need to write them also, we don't need to write them. So E is basically E is 14. So you have to move 14 units from starting from D. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, B. So this is okay. From 1, if we start, D is basically, D means 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. We reach here. And again we have to go 12 units. 1, 2, 3, 4, 5, 6, 12. We reach it to A. So this is also good with us, and this is like this, that is fine. From A we need to move 12 units. 1, 2, 3, 4, 5, 6, 7, 12. This is also fine. So this should yield correct result. So you just again verify with the decimal equivalent. So whatever decimal equivalent is coming, you check what is coming here, whether this gets added to give the correct result or not. So in this particular lecture we have seen how to do addition in decimal also we looked at, and then we generalized the algorithm for binary, octal and hexadecimal. So and we also saw this clock, which is very useful for any particular radix. If you have, you can always use this clock, and just this is just counting now, so nothing else. So you don't need to remember that the addition, whatever the added value is, you don't need to convert it in your head to the particular number in the particular number system. Just keep on counting and just note how many times you have crossed 0, and you will get the answer. from this block. So wherever you reach, you put it here, and how many times you have crossed 0, you take it as a carry. So that will give you the result. So this is all from the addition part. So I hope any number in any number system, if you are given any two numbers, any three numbers or four numbers also, as many numbers as you might be given, you will be able to add them up. Thank you for your attention, and then in the next lecture we will see how to do subtraction of numbers. Thank you.